In this recording, I'm going to introduce valeric acid, its chemophysical properties, bond types, hybridization, and classification of carbons along with their associated counts. So to begin, the molecular formula of valeric acid is C5H10O2. The 5 carbons can be distinguished via these vertexes in the structure. So 1, 2, 3, 4, 5 carbons, 2 oxygens, seen here, and 10 hydrogens, which can be seen with this CH3. So 3 hydrogens, these are all CH2s. So that's altogether that's 9, and this last one, and this alcohol, so that's 10 hydrogens. And this compound also has 1 degree of unsaturation. This can be seen with the oxygen double bond, carbon-oxygen double bond. The functional groups present are a carboxylic acid functional group, which is made up by this carbon double bond to oxygen and an alcohol. That makes up the carboxylic acid, along with this alkane chain. Those are the 2 functional groups. The molecular weight of valeric acid is 102.07 grams per mole. Melting point at negative 34 degrees Celsius, boiling point at 186.1 degrees Celsius, and the physical state of valeric acid at 25 degrees Celsius is a liquid. Now down to the bond types. There are 16 sigma bonds throughout the compound, and that represents all the carbon to hydrogen bonds, the carbon to carbon bonds, the carbon to oxygen bonds, this oxygen to hydrogen bond, as well as part of this carbon to oxygen double bond. That sums up to 16 sigma bonds. The 1 pi bond present makes up a part of this double bond, so there's 1 sigma, 1 pi. The hybridization of carbons can be seen with 4 sp3 hybridized carbons. So these are all single bonded, 1, 2, 3, 4. And then we have 1 sp2 hybridized carbon bonded to this oxygen, which forms a double bond. We do not have any sp hybridized carbons in this molecule. In regards to carbon classification, for CH3 we have 1 CH3 at the end of this alkane. And CH2s, 1, 2, 3 carbons bonded to 2 hydrogen substituents. And we do not find any CHs, but we do find 1 carbon that is not bonded to any hydrogen substituents in this carboxylic acid functional group. So I will now show you how to build the physical structure for valeric acid with the Snatoms molecule kit. So to begin, to the right, I drew the Lewis-style structure for valeric acid, along with, on the left, the condensed structure, and then the molecular formula for valeric acid is C5H10O2, with 5 carbons, 10 hydrogens, and 2 oxygens. So before we get started, I'd like to mention that we have 2 functional groups present in this molecule. We have our alkane sp3 carbon chain, our linear chain, bonded to the carboxylic acid group with this carbon double bonded to an oxygen and alcohol. That represents the carboxylic acid functional group. To recap, sp3 hybridized carbons are just carbons single bonded, sp2 double, and sp triple bonded carbons. Each atom will be represented by their associated snatom. The hydrogen atoms will be the white snatoms, carbons black, and oxygen red. So as we'll notice, each atom has its own place to bond other snatoms to magnetically, and this represents the need for atoms to become more stable via the octet rule, which just refers to the tendency of atoms to prefer to have 8 electrons in their associated valence shell. And because of this, when atoms do have fewer than 8 electrons, they tend to react and form more stable compounds. So that's why we want to build this molecule to produce stable atoms. Therefore, we will start building our linear carbon chain, and then start adding our hydrogens, superfill carbons and hydrogens, octet rule. And this is our CH3 carbon that can be seen, and we'll start building our CH2s. And then now we will add our double bonded oxygen. And I'll use these 2 clips to represent the double bond. And then we will add our alcohol group. So as we can see, we can determine that this chain is going to be the alkane chain represented here, and our carboxylic acid group is going to be represented by this molecular structure. Carboxylic acid, alkane chain, bonded together to form valeric acid. And that is how to build the physical structure for valeric acid.